From space, Earth appears as a swirling blue marble, our blue planet, shimmering with life and possibility. It's covered in water, stretching from horizon to horizon, but here's the catch. Almost all of it is salt water, not fit for us to drink. About 97% of Earth's water is locked away in the oceans, undrinkable for humans and most land animals. Of the tiny 3% that's fresh, the vast majority is frozen solid, trapped in glaciers and ice caps at the poles, far from where most people live. That leaves less than 1% of all the water on Earth as accessible fresh water, enough to fill our rivers, lakes, and underground aquifers, but not much more. This tiny slice supports billions of lives, fueling our cities, nourishing our farms, and powering industries around the globe. As our population grows and cities expand, the demand for this precious resource skyrockets, putting more pressure on what little we have. We have to be smart, protecting, conserving, and finding new ways to get fresh water, from fixing leaks to inventing new technologies. The paradox is clear: a world awash in water, yet so little of it is actually usable for drinking, farming, or industry. That's why scientists and engineers are turning to the biggest source of all, the ocean, searching for ways to unlock its potential. The challenge is enormous. Can we turn the vast, salty sea into something we can safely drink and use every day? Every drop of fresh water is valuable, and every solution counts in the quest to secure our future. Let's see how people around the world are working together to tackle this global puzzle and ensure clean water for generations to come. What happens when a major city runs out of water? Imagine waking up to find the taps in your home have stopped running, and the city around you is scrambling for every last drop. It's not science fiction, it's reality for places like Cape Town and Mexico City, where millions have faced the terrifying prospect of a waterless future. Cape Town nearly hit day zero, when the taps would run dry and residents would line up for daily rations. People were forced to adapt, collecting water from public stations and rationing every liter. The problem wasn't a lack of water nearby, the city sits on the coast, but a lack of fresh water in reservoirs after a severe drought. Salt water was everywhere, but drinkable water was dangerously scarce. Mexico City faces its own crisis, sinking as it pumps out underground water, leaving millions without reliable access. The city's foundations are literally dropping as aquifers are drained faster than they can refill. These cities show how fragile our water systems can be, and how quickly a modern metropolis can be brought to its knees by water shortages. Climate change brings more unpredictable rainfall and longer droughts, making it even harder to plan for the future and protect our water supplies. Growing cities mean more people, more thirst, and more strain on limited supplies. As populations swell, the demand for water only increases, putting extra pressure on already stressed systems. We can't make it rain, so we need smarter solutions. Innovation and careful management are now more important than ever to keep cities running. That's why so many are looking to the ocean for answers. The vast blue expanse could hold the key to our survival. What if we could turn seawater into drinking water? Scientists and engineers are racing to make this a reality, developing new technologies to quench our city's thirst. The search for a new source is on. Let's find out how cities are fighting back against water scarcity, and what the future might hold. Surrounded by oceans, so why not just drink the water? The problem is salt. Seawater is loaded with salt, far too much for our bodies to handle. Drinking it actually dehydrates you, making you thirstier. Our kidneys can't process all that salt, so we lose more water than we gain. That's why sailors lost at sea can't survive on ocean water. To make seawater safe, we have to remove the salt, a process called desalination. Early methods like distillation, boiling and collecting steam, worked, but were slow and energy intensive. We needed a better way to make fresh water from the sea. Enter modern science and engineering. Desalination is how we turn the undrinkable into the drinkable. But how do we do it efficiently and at scale? That's the next step in our story. Let's dive in. The most popular modern method for desalination is reverse osmosis. Imagine a superfine filter, so tiny only water molecules can pass through, leaving salt and impurities behind. In a desalination plant, seawater is pushed at high pressure through these special membranes. The result: fresh water on one side, concentrated salty brine on the other. It's like squeezing juice from an orange. The pressure separates what we want from what we don't. This process is happening in thousands of plants worldwide. Seawater's filtered, pumped, and transformed into clean water. The technology is impressive, but it's not magic. It's science and engineering at work. Reverse osmosis has made large-scale desalination possible, but it comes with challenges: energy use, cost, and what to do with the leftover brine. Still, it's changing lives in cities. Let's see how one country made it work. Israel, a dry country with little rain, faced constant water shortages. For decades, the land was parched, and the people had to be creative just to survive. Water was precious, and every drop counted. They mastered conservation, like drip irrigation, a revolutionary technique that delivers water directly to plant roots, minimizing waste. But even with these efforts, it wasn't enough to meet the growing needs of the nation. So, they turned to the Mediterranean Sea and built some of the world's largest, most advanced desalination plants, transforming salty seawater into fresh, drinkable water on a massive scale. The Sorek plant alone produces hundreds of millions of liters of fresh water daily, enough to supply entire cities and keep communities thriving. Today, over 80% of Israel's drinking water comes from desalination. Clean water flows from taps in homes, schools, and businesses, even during the driest years. They're essentially drought-proof, rain or shine. Parks and gardens flourish where once only dust and rocks remained. How did they make it affordable? Innovation. Israeli scientists and engineers worked tirelessly to find new solutions. Israeli engineers developed energy recovery devices, capturing leftover pressure from the process to power the next batch, saving huge amounts of energy. They also improved membrane technology, making filtration faster and cheaper and allowing plants to operate more efficiently than ever before. These breakthroughs slashed costs, turning desalination from an emergency fix to an everyday solution that supports millions of lives. Israel's success shows what's possible with determination and smart engineering. Their journey is a testament to human ingenuity. They wrote the playbook for the world, sharing their knowledge and inspiring other nations to follow their lead. But even with success, new challenges emerged. Environmental concerns and questions about long-term sustainability began to surface. What happens to all the leftover salt? Let's find out as we explore the next chapter in Israel's remarkable water story. For every liter of fresh water made, desalination creates even more super salty brine. Most plants pump this brine back into the ocean, but it's much denser than seawater. It sinks, forming salty layers on the seafloor, harmful to marine life and ecosystems. Brine can also contain traces of cleaning chemicals, adding to the risk. Engineers are working on solutions. Special diffusers spread the brine over larger areas, diluting it to minimize harm. The goal is to return water to the ocean as close to normal as possible. We must solve the water crisis without creating new environmental problems. Protecting the ocean is as important as quenching our thirst. The challenge: how to handle brine safely and sustainably. But what if brine could be more than just waste? Let's explore new possibilities. What if brine wasn't just waste, but a resource? Brine is packed with valuable minerals: magnesium, calcium, potassium, even lithium. Scientists are developing ways to extract these elements, a process called brine mining. Imagine desalination plants producing not just water but also industrial salts and minerals for batteries and manufacturing. This could make desalination cheaper and safer for the environment. It's a circular economy turning waste into valuable products. Some projects even use brine to grow salt-loving algae for biofuels or in fish farming. By finding creative uses, we reduce environmental impact and add value. Science turns challenges into opportunities. The future of desalination could be even brighter. Desalination technology keeps improving, cheaper, cleaner, and more efficient. Solar-powered desalination is on the rise, using sunlight to power plants or heat water directly. This is perfect for sunny, dry regions with little access to electricity. Another breakthrough: graphene membranes, ultra-thin, super-strong filters that could make desalination faster and use less energy. These innovations promise to make fresh water accessible to more people, with less environmental impact. The future may see desalination plants powered by the sun and filtered by advanced materials. Science and engineering are opening new doors. The next generation of solutions is on the horizon. The future of water is bright and less salty. Let's remember what's at stake. Earth is a blue planet, but only a tiny fraction of its water is drinkable. Cities worldwide are facing water crises, pushing us to innovate. Desalination, especially reverse osmosis, offers hope, turning oceans into a reliable water source. Israel's story proves it can work, with smart engineering and new technology. But desalination brings responsibility. Brine must be managed to protect marine life. Innovation is key. Safer brine disposal, brine mining, and clean energy solutions. The goal: a system that works with nature, not against it. Desalination is a vital tool, but conservation remains essential. For many, it's a lifeline and a symbol of human ingenuity. As we perfect this technology, we must protect our oceans for future generations. We have the power to turn seawater into drinking water, and the duty to do it wisely. Together, we can solve the water puzzle. Science is our guide.